Hi guys, so today I am going to kind of demonstrate to you my die rolling experiment. So why did we even do this? So the problem is my roommate is suspiciously too good at board games, and not just any board games, but games that involves dice. And that led me to suspect, am I being skeptical or is it really that the die is biased? And so I want to investigate this. To investigate this, I can't run a die for an infinite amount of times. Like, that is just impossible. I can't collect every possible trial and outcome of that die's lifespan. And so, what I will be resorting to now is statistics. What I will do is I will take this die and roll it 150 times, and then using the chi-squared goodness of fit test, I will analyze based on my little sample of 150 trials whether this die is fair or if not, or not. I'll also be using a significance level of alpha 0.10. So, a little background, what is my null hypothesis for this experiment? The die is fair. What is my alternative hypothesis? Is that the die is not fair. A little background on the chi-square test. So again, the chi-square test is just basically a way of how to measure, is basically a way to measure how different my results are from what I expected to happen. And and okay, so in real life, we can't just what happens is not necessarily going to be exactly of what we expect due to, just natural randomness that happens in life. And so to kind of scope in on that nuance, like is that nuance due to randomness or is that nuance actually due to it being too out of scope and too unfair? To kind of quantify that, we will be using the chi-square test. A little bit of the math. So this is like the equation. So your chi-square test is basically a summation. We're going to take the outcome minus by expected, square that, divided by expectation. And the important takeaway is if you have a small chi-square, that means it's closer to expected, it's more fair. If you have a big chi-square, it means your results are a bit far from your expected, and that can possibly be unfair. And now we will kind of jump into collecting our 150 rolls. I have recorded all my data on a Google Sheet if you're interested in seeing each trial individually, like one all the way to 150, but I've also summarized it visually and in this chart. Now to the statistical analysis. So again, our data, so this big is not a zero, it's an O. So O here stands for observed. So observing one, what happened 28 times, we observed two, 23 times, observed three, 20 times, observed four, 24 times, observed five, 36 times, observed six, 19 times. To calculate our expectation of a fair die, there's six outcomes, each have an equal probability of 1 over 6, and since we rolled this die 150 times, we're going to multiply the equal probability by 150 and get expectation of 25 for each possible outcome. Now we will calculate our chi-square test. So we're gonna start with 1, take 28 minus 25 squared, divide by 25. So we're taking observed, minusing by expected, and squaring that, dividing by the expected. And we calculate that and get a 0.36. We're going to repeat this math for observed number 2, observed outcome 3, observed outcome 4, observed outcome 5, observed outcome 6. Afterwards, we'll summate all of this and get our chi-square statistic of 7.84. Now to calculate our critical value. So we're going to take a degrees of freedom, 6 minus 1. 6 is coming from our possible outcomes of 6, and get a degrees of freedom of 5. Remember, our significant level alpha is 0.10. We then, from our chart, can get our critical value to be 9.236. Now, how can we make our decision with this information? So now, using our chi-square test statistic that we found earlier, and using our critical value, we will now compare them to see whether we can reject or fail to reject our null hypothesis. If our chi-square test statistic is greater than our critical value, we can reject the null. However, if it isn't, that means we fail to reject the null. Now, in our scenario, we got 7.84 for our chi-square test statistic, and that is indeed less than 9.236. That means we fail to reject our null. So again, just a reminder, that means we fail to reject the fact that the die is fair. So to conclude, what this all basically means is at the 10% significant level, so specifically alpha of 0.10, my data does not provide evidence that the die is unfair. This is not to conclude and prove that the die is fair and unfair. Rather, we're just saying we don't have evidence to say that the die is unfair. And this basically means that the differences between our observed outcomes for our 150 trials and expected counts are small enough to be explained by normal random variation. So, am I skeptical? Maybe, maybe not. For now, I will accept that my roommate does have good dice board gaming skills, as I have failed to reject that the null hypothesis, as I have failed to reject the null hypothesis that the die is fair. However, we want to remember that this is all on a single trial of only 150 rolls, and while the data for now is consistent with a fair die, the small sample size may have resulted in insufficient statistical power, and we might be having a type 2 error. Thank you.